In this video, we will learn how to use callbacks to control model training in TensorFlow. This can be done by training loops. Let's understand what is callback. A callback is a powerful tool to customize the behavior of a Keras model during training, evaluation, or inference. For example, if we define number of epochs is equal to 10, but while training our model at epoch number 5, our loss goes down to 4%. And we want our model to stop training at that particular epoch, then we use callback. It will stop the model training at a particular loss percent. Let's import TensorFlow. From TensorFlow, import Keras, import NumPy as NP. Let's also understand what is an epoch. An epoch is the number of times we train our model. For example, if epoch is equal to 10, then we want to train our model 10 times. Let's execute our code. First, we will develop a model without callback. Then we will develop the model with a callback. We will be working on the MNIST dataset, which is available inbuilt. I'll import TensorFlow as TF. I'll write down here as TF. Let's execute our code. We are going to work on the MNIST dataset. I'll make one variable MNIST from TensorFlow.keras.dataset. In dataset, we have a lot of dataset available, and from this we will call the fashion MNIST dataset dot fashion MNIST. Let's execute our code. Next, we will make two tuples. First tuple will contain the training images and training labels. The second tuple will contain test images and test label. Let's make two tuples, training images and training labels. The second tuple will have test images and test labels. We will call this from MNIST. We have defined here MNIST. We will call this variable MNIST here, and from this we will call the load underscore data. Let's execute our code. We have successfully saved our data into training images, training labels, test images, and test labels. Let's print the shape of training images and test images. Training images dot shape. We have 60,000 samples in training images, and the image are of 28 by 28 pixels. Let's also look at the test images. Test images dot shape. In test data, we have 10,000 samples, each of 28 by 28 pixels. We will look at the numbers present in this training images and test images. Let's look at the minimum and maximum number, that is in train and test, and also check the data type. I'll call NumPy, and then I will call the function min, and I will pass training images. In training images, the minimum number is 0 and the data type is integer. Let's also look at the maximum number, np.max training images. The maximum number is 255 and it is integer. Let's also do the same for test images, np.minimum test images. In test images, the minimum number is 0. np.max of test images, the maximum number is 255. Let's bring down the minimum and maximum numbers between 0 and 1. Here we have minimum as 0 and the maximum as 255, but we want to bring this maximum to 1, and the number will lie between 0 and 1. And we also have to convert the data type into float by dividing all the samples by 255.0, because TensorFlow works very good on float dataset but not on integer. I'll make one variable train images or training images, and then I will call training images, and I will divide this by 255.0. Here I am dividing all the samples by the greater number, and the number is 255.0 because I want to convert the numbers into float. That is why here I am taking zero point 0. Similarly, I will do that for test images also. I'll call the variable test images. Then I will divide the test images by 255.0. Let's execute our code. So we have successfully converted this into a float, and all the values will lie between 0 and 1, and we can verify that. I'll just run the code here. Let's run it. Here you will see we got 0 point 0 instead of 0 because we have converted this into float, and here we will get 1.0. Let's execute our code. In the output you can see that we got 1.0. Here also we will get 0 point 0 instead of 0, and here we will get 1.0. You can see that we have successfully bring down all the numbers between 0 and 1 and also converted the numbers into float. Next we will define the model. I'll make one variable model. This model is without a callback, and after this model we will define the class callback and then use that in our model. From TensorFlow.Keras.models, let's call the class sequential. This is going to be a sequential model. Next we will define the layers from tf.keras.layers. The first layer will be the flatten layer. Next we will define the dense layer from tf TensorFlow.Keras.layers. Define the dense layer, and here we will type 512. 512 are the number of neurons. Activation we are going to use the ReLU. There are many different activation function, but in this example we are using the ReLU activation. Next let's define the last layer, the dense layer, tf.keras.layers.dense, and this time we will pass 10 because in our target variable we are having 10 classes. That is why we are defining 10 here, and our activation function is going to be softmax, because when we have multi-class level, when there are more than 2 class, we will be using softmax. Let's execute our code. We got one error here, flatten. I have to put n here, flatten. I have to put capital F here. Let's execute our code. We have defined the model here. Next step is to compile the model, and when we compile the model we define two important things, the optimizer and the loss function. From model let's call compile. We will first define the optimizer. Optimizer is going to be Adam. There are many different optimizer. In this video we are using the Adam one. Then we will define the loss function. Loss is equal to sparse categorical. We will define sparse categorical underscore cross entropy, and we are using this loss function because our target variable has 10 classes. When you have more than 2 classes you have to use this loss function, sparse categorical cross entropy. Let's execute our code. I have to write I here, there's a spelling mistake. Let's run our code again. We have compiled our model. Next we have to fit our model, and this is the final step. Let's fit our model, model.fit, and we have to fit it on training images and training labels, and we will define the number of epochs. Epoch is equal to let's say 5. Let's execute our code. This model will run 5 times and calculate the loss. Here you will see that our loss is 4% at the first epoch. It is going down to 3% in the second epoch. In the third epoch, it is 0.3 again. And in the fourth epoch, the loss is coming down to 0.3. In the fifth epoch, the loss is 0.2%. So here you see that we have fit the model and we have defined the number of epochs. Now we will work on the callback, and before that I will explain you what we are going to achieve with the callback. Here you will see that we have defined the number of epochs is equal to 5, and we want to write a callback. We want to say that once the loss reach to 4%, then do not train this model, just stop it there. For example, here you will see here our loss is 0.47%, but since we have defined the number of epochs is equal to 5, this model will continue to run until it will complete the 5 epoch. But using callback, we can stop the model at a point when we reach the desired loss percentage. We want to define a callback in which we will say that once the loss reaches the 4%, 0.4, just stop the model even if the number of epoch is 5. Let's define a class, and we will define a class for callback. Class myCallback. Class name is myCallback, and this will take tf.keras.callbacks.callback. Inside this we will define a method. Anything defined inside a class is known as method. In general we call it as function, but when we write it inside a class it is known as method, and it can be written using the def keyword, def. Then next we have to write the method name. The method name is on epoch underscore end. I'll pass the parameter self. This will take the parameter self by default. The next parameter is epoch, and the last parameter it will take logs. Then I'll write the condition if logs dot get. I'll explain you code once I finish writing. Loss is less than 0.4, print, and this will print in a new line /n. This /n indicates this will print in a new line. Loss is low, so stop training. Self dot model dot stop training is equal to true. Let's execute our code. Now we will instantiate this class myCallback and save in an object. I'll make one object callbacks, and then I will call this class myCallback. Let's execute our code. Now I'll copy this model.fit from here. I'll paste it here, and I will pass a parameter callbacks is equal to. Inside this I will pass this object callbacks. Let's execute our code. The model has started training. The loss is 0.25, and you will notice here that we have defined the epoch as 5, but after the first epoch, since the loss came down to 0.2, it stopped training the model, and here you can see the message loss is low, so stop training. Here in our class myCallback we have defined one function, and the function name is on epoch end. This will take parameters self, epoch, and logs, and it is here writing the condition If logs dot get loss, if the loss reaches less than 0.4, then just stop training the model and print this loss is low, so stop training. Here you will notice that our loss is 0.25. Since this 0.2 is less than 0.4, so the model training has been stopped and we got the message here, loss is low, so stop training the model. This is how the callback works. If I remove this, if I just cut this, and if I run this again, you will see this model will train 5 times. Here you will see 1 by 5. This model ran only for once, and now if I run this again, this model will run 5 times. Let's execute our code. This is the first epoch. The loss is 0.2. Now you will see, you can see here, this is the second epoch. The loss is 0.2. This is the third epoch and the loss is 0.2. This is the fourth epoch, loss is 0.2 here, and this is the fifth epoch. It will run until 5 times because we have defined the number of epoch is equal to 5. But when we pass the parameter callback, I'll pass the parameter callback, and here in callback we have defined this class callback, and inside this we have defined a function, and this function says that if your loss is less than 0.4, just stop training the model. I'll run this code again and I will show you the difference. Let's execute our code. In the output you will see, you can see that the loss is 0.1% now, and this will stop. This has stopped training the model. We got the message loss is low, so stop training them, so stop training. This is how the callback work. When you reach a desired loss function, the desired percentage of loss, you can stop training your model, and that can be achieved with the help of callback. This video was about callback in TensorFlow. If you like my video, please subscribe to my channel. Thank you for watching.